Welcome. Machine learning helps customers make major breakthroughs in personalized recommendations, accurate demand forecasting, predictive maintenance, pretty much any use case you can imagine. But how long is it taking you to build those new models? 3 months, 6 months, a year? And why is it taking so long? Well, a big part of that is preparing data and doing feature engineering. And unfortunately, this takes way too much time. In the next 30 minutes, I'll show you not only how you can prepare new features much more quickly, but also how you can share features and reuse them across teams. My name is Mark Roy, and I'm an ML architect at AWS. I've been designing and building software for decades, and these days I spend most of my time helping companies architect ML solutions at scale. We've got a lot to cover, so let's jump right in. Here's our agenda. I'll start with an overview of Amazon SageMaker Data Wrangler and Feature Store. And then I'll go deeper on each of these, and I'll do that also with a set of three demos. The first demo will take some raw data, do some feature transformation and visualization using Data Wrangler. The second demo will take those resulting features and ingest those into the Feature Store. And the third demo will use existing features in SageMaker Feature Store in order to train a model. So let's jump into the overview. Data scientists spend up to 60% of their time on data preparation. So this includes getting access to the raw data sources and doing various feature engineering, visualization, data cleansing, handling missing values, removing outliers, and so forth. This can be a really expensive bottleneck in the process of delivering machine learning models. Unfortunately, this is often made worse in that teams do this from scratch. So let's take this insurance company example where one team has to build a damage assessment model for vehicle damage, and they have a number of different data sources. So they go through the process of data engineering and feature engineering, data cleansing, and so forth for each of these, and they operationalize that in various feature pipelines. And unfortunately, another team doing a customer churn model does the same thing, and a third team doing a recommendation model also does that. So we've got very little reuse happening and a lot of expensive feature engineering and data preparation. So how does Amazon SageMaker help address these challenges? Well, a couple of brand new modules in SageMaker as of late last year are provided. The first is Amazon SageMaker Data Wrangler. Data Wrangler helps you quickly access data sources, a wide variety of them, and easily transform your data. There's over 300 built-in transformations. There's an ability to do custom transformations with pandas and PySpark and SQL. You can also do visualization of your data to understand relationships between different columns and features, and even prepare your own custom charts easily. You can, while in the tool, you can estimate model accuracy, you can look at bias in your data. And then lastly, you can also operationalize these data flows, and we'll see that in some of our demos. The second component is SageMaker Feature Store, which allows you to securely discover and share and reuse features for both real-time inference as well as training. So Feature Store provides both an online and an offline store, and it keeps the features in sync between the two automatically for you. You've got feature metadata available to help with feature discovery and reuse. And Feature Store is secure as well, giving you encryption as well as access control to decide who can use which features. This is a fully managed solution, allowing you low latency access for online inference as well as access for extracting training data sets and batch transformation. So in that insurance example, the new process would be using Feature Store to share all of these different feature pipelines so that the first team can use those and then other teams can reuse those as well. So you can automatically take advantage of reproducible feature pipelines. You can easily extract training data sets, and you can support on low latency predictions using feature vectors from Feature Store as well. To give you a little context of how these modules fit into a bigger picture, Amazon SageMaker is an end-to-end machine learning platform, providing you capabilities for preparing your data, building models, training and tuning those models, as well as deploying and the ongoing management and monitoring of machine learning models at scale. This is all supported by a SageMaker Studio IDE as well to tie together all these modules. And what we're talking about today is two of the modules on the left here, SageMaker Data Wrangler, as well as Feature Store. I encourage you to look at all of the available capabilities, even though we won't cover them in detail today. So with respect to the demos that we're about to go through, we're going to have an example where I'll be showing you how to produce a model that will predict flight delays. So is my flight going to be delayed by more than 15 minutes? And we'll start with data from the US Bureau of Transportation Statistics. We've got flight delay historical data, and we'll look at all of the flights across the US for a 3-month period. Turns out to be a couple million rows with 26 different columns that we can take advantage of. So let's jump into the first demo. Okay, let's get started with the demo. From the Studio homepage, we can just click New Data Flow. That will get us into a new Data Wrangler flow. We're going to pull our data from S3, so we'll navigate to a set of buckets, find our CSV file. It's got a couple of million rows in it. We'll import that. And you can see Data Wrangler lets you prepare and analyze and export. So let's click on Analyze, and I will do Add Analysis here. And we can do a quick histogram. I will do departure delays. I'll check out departure delay group, which looks at the severity of the delays in flight departures. That looks pretty good. I'll save that. Let me create a new analysis. I'm going to do a scatter plot. I've got a hunch that departure times may have an impact on delays. So let's take a look at that quickly. So we'll put departure time versus departure delay group, and let's take a quick look. And in fact, as you get later in the day, you're going to get more and more flight delays. So my hunch was correct. You can even look at this by different facets. So if we say, let's get a chart based on each of the states that the flights are originating from, you can group it that way. And I'm going to save this. So now we've got a scatter plot. You also, and this is a unique thing with Data Wrangler, you can also add your own custom code. So for charting, for example, you get a little code snippet here. You can use the pandas data frame and output a chart using Altair. So here I'm going to use Altair charting to look at the airline carrier versus the average departure delay. So I'll check that out with this preview, and you can quickly do whatever customizations you see fit. Okay, so that's some analysis quickly. Let's do a few data transformations. Data Wrangler gives you access to several hundred different transformations for dealing with date columns, categorical columns, strings, text, scaling of numerics. You can even deal with missing values and outliers. So let's just quickly try a couple of them. Here I'm going to remove all of the outliers for departure delay new. I'll call it departure delay core data. So I'm going to remove anything that's more than 3 standard deviations away from the mean. So Data Wrangler does that, creates this new column for me. So I'm going to add that. What I can also do is, just like in the charting case, I can add custom transforms. So let's do some pandas. I've got a few lines of pandas code that I've crafted ahead of time here. I'm just going to toss those in there. And what I'm doing here is I'm adding a departure hour feature to get a less granular form of the time. That's going to be convenient. That might provide some signal. And I'm also adding a record ID and an event time. These will be useful because I'm going to export all of the results to Feature Store. And Feature Store requires that you uniquely identify each record and provide a timestamp so that it can maintain the history of the features over time. So I'll let Data Wrangler produce those new columns as features, and that'll just take a couple of seconds, and there you have it. So I can add those. And then lastly, you can also add PySpark SQL. So if you're used to working with PySpark or PySpark SQL, here's an example where I'm just getting the average of the delay of a departure, calling it the average flight departure delay for the last 14 days. And I'm using a SQL window clause here to look at the 14 preceding days. So I'm going to quickly add that column as well. So I'm hoping that might provide some insight into departure delays. Okay, so I've added that. So we've looked at quickly at visual analysis, built-in transforms, custom transforms. And if we go back to the data flow, we've actually got a number of steps that we've built out with outliers, some pandas code, some custom SQL. Now we'll go to the Export tab, click on the final step, and click Export Step. We've got options to export, run the Data Wrangler flow and export to S3. We could use a SageMaker pipeline. We can export to Python code. We are going to export to Feature Store. That will automatically generate for us a brand new Jupyter notebook that will load the flow file to S3. It will create a brand new feature group for us, and then it will run the steps in the flow and ingest the data to Feature Store. The only change you need to make to the notebook is to identify the record ID and the event time. Remember, we created these new features in the data set, but this notebook needs to know which of them is used as the record ID and the event time. With that, we can save the notebook and run all cells, and that will be the end of this demo. Okay. Now let's take a deep dive on feature ingestion. So to do so, let's take a step back here and look at Feature Store in a larger context. SageMaker Feature Store gives you both an online store and an offline store. The features that get added to the online store are automatically synchronized to an offline store. The online store gets used for really low latency access to do model inference. The offline store is used for extracting training data sets as well as data sets for doing batch transformations or scoring. You can use a number of different ways to get features into Feature Store. Streaming ingestion will take sources of data from places like Kinesis as well as Kafka, and you can use a feature pipeline to directly ingest into the online store. Likewise, you can do batch ingestion where you might access data from an operational data store or from S3 and do transformations that will also ingest into the online store, but maybe do so on a scheduled basis, let's say nightly or weekly or hourly batch ingestion. So how does that actually get done at the lowest level? This is a 300 level talk, so let's talk about some of the APIs involved. There's two different APIs for inserting new feature values. The first is the put record API, and that simply takes the name of your feature group as well as a feature record with all of the name value pairs for that particular feature record. Alternatively, you can use the SageMaker Python SDK, which gives you a feature group object and an ingest method. The beauty of this is that you get to pass an entire pandas data frame, and that method will automatically ingest all of the rows in that data frame, and you get to control things like the number of processes that it will use in parallel to do that ingestion efficiently. So you've got raw data, you've got feature pipelines, and you're getting them into the feature store. What are the different options you have for doing that in a reproducible fashion? The first would be, let's say your company does a lot with Hadoop and Spark, and you've got existing EMR clusters. You could just extend those Spark jobs to also do ingestion to the feature store. Alternatively, you can use something like SageMaker Processing, which gives you an easy way to simply bring a Python script to do either PySpark processing or let's say with scikit-learn. And from those scripts, you can actually ingest directly to the feature store. The last option is also using processing jobs, but using the Data Wrangler built-in container for doing this. And that's what we'll talk about in more detail next, and then we'll have a demo on using that as well. So if you remember the Data Wrangler export capability, you picked your final step that you're going to export. You export the entire flow, and that gives you a Jupyter notebook. What that notebook does when you run it, one, it pushes the flow file to Amazon S3. Second is it creates a new feature group for you. The third is it starts a processing job that will transform all of the input data to features using the flow that you defined. And then the last step will be to ingest into the feature store. And this step 3 here is all done with the built-in Data Wrangler container. Let's take a closer look at how that looks with an overall architecture diagram. So you've got your Data Wrangler flow file that you created. You've got the raw data sources, and you're basically running a SageMaker processing job, which will execute a set of the feature engineering steps that you prepared using Data Wrangler. At the end of the final step, it will do a bulk ingestion of the resulting data set. These features get loaded into the feature store, into the feature group name that you specify. And as with any SageMaker processing job, you get to control the cluster configuration, which defines exactly which instance types you'll use and how many of them you want to use. That will control the speed and duration of the job. This feature pipeline could also be part of a larger overall pipeline. So there's a new capability that SageMaker provides called SageMaker Pipelines, which allows you to define a multi-step flow that could include this feature pipeline as a subset, and then it could go on to do training, model valuation, registering your model, and so forth. These pipelines can be executed on demand, or you could set them as part of a schedule, let's say to run weekly or daily. They can also be triggered either by checking in a new code or by arrival of new data. And that's what we'll show in a demo. You can use Lambda as well as Amazon Event Bridge to help with the scheduling and automatic execution of SageMaker pipelines. Okay, let's go to demo number 2. Where we'll show you how to ingest features into the feature store. Okay, when we left off, we had launched a processing job via the generated Jupyter Notebook that took care of uploading the flow file, creating a new feature group, running our data flow that we had prepared, and then taking the results and ingesting them into our new feature group. So that ended up producing 1.7 million records in our offline store. We also can take a look here at the distribution of those flight records across different dates. You can see they go everywhere from January 1st up to March 30th. So now what I want to show you is let's copy a file with March 31st data into S3. So we'll copy that file, and what's happening now is we've got an S3 trigger set up so that when it detects that a new file has arrived of the right type, it will automatically trigger the SageMaker pipelines to ingest all of this new data into our existing feature group. So let's switch over to take a look at the pipeline and see if things have kicked off. And voila, we've got the pipeline kicked off immediately. And you can see it is executing. It's a very simple one-step pipeline which is running a processing job to execute that data flow that we created earlier. This will take a few minutes to run, so let's pause the video here and I'll come back and show you the results. We are back. As you can see, the pipeline completed successfully. It took about 6 minutes to run. We waited a few more minutes to make sure the records replicated from the online store to the offline store. Now let's go take a look and be sure everything worked okay. As you remember earlier, let's just kick off this query here. When you remember before we triggered that pipeline, the records were from January 1st through March 30th. The most recent day had about 9,600 flights. Now we had uploaded our March 31st data. The pipeline completed. It did all those transformations for us. It ingested the new data in this feature pipeline. And now we've got data for March 31st. So that is the end of this demo. Okay, let's go deep into how you can work with a SageMaker offline store. So once you have data in SageMaker Feature Store, in this example, we've got an offline feature store on the left here with a number of different feature groups established. We've got features about customers, orders, claims, and website visits, let's say. You can query that using Amazon Athena, which takes advantage of a Glue data catalog or other types as well. And so doing a query is as simple as using SQL to do a select. Here we're selecting a few different features of a customer feature group to get a training data set prepared, and then I can run SageMaker training with that result. Here's another example where you might select a different set of features from the same feature group and produce an input file for doing a batch scoring job. You can interact with Athena in a couple of different ways. You could use the console, so interactively you can experiment with various queries and get those results. Or you can use the Python SDK. So if you're using the SageMaker SDK, you can use queries here. There's an Athena query object that's made available that will translate for you to get the exact table name that you need to use. You can also not only run the query, but there's a built-in waiter. And then when the results are available, you can extract directly into a pandas data frame as well. Okay, let's look at what's happening under the hood. So in S3, you can see the structure of the S3 folder on the right. So for any given feature group, there's a data folder, and under that, the data is partitioned by year, month, day, and hour. And SageMaker Feature Store will automatically produce compressed Parquet files partitioned by event time, and this will give you full feature history for your ML features. You can do point-in-time correct data sets extraction from the feature store since you've got all of that full history available. Okay, let's go to our final demo. Okay, let's get started on the final demo here, where we'll focus on training using features from the offline store. To keep things interesting, let's imagine that a separate group in our company has been working for months on putting together features about weather history. So this will be a great signal for flight delays, of course. And so they've done months of work to fine-tune that, and they just released a new feature group for it. So here we get the 1.7 million records from the feature store for flight delay history. Here we take a look at the brand new feature group. They're actually on version 3 now. You can see they've got minimum and average temperatures, they've got snowfall, precipitation, average wind speed, and peak wind speed for a 2-minute period on that given day. The record identifier for these records is the actual airport location. So let's grab that data into a data frame, take a quick look at it. We've got, I've been told that they've only populated the data for Boston so far. So let's grab a subset of our data, our flight delay data, focused on Boston as well. That gives us 34,000 records with 34 features. Let's join that with the weather data that we got from Feature Store based on the weather date. So now we've got 55 different features. Let's take a look at some of that data in that combined data frame. And here we're just doing a train test split, and we're going to train an XGBoost classifier that will predict based on the departure hour, the average flight departure delay over the last 14 days, and then some of the weather data, precipitation, snow, minimum temperature, this peak wind speed over a 2-minute period, and the average wind as well. So we'll quickly train an XGBoost model, and then we'll do predictions of departure delays for the test data frame, and we've got our results. So great example here of just optimizing the data preparation work of flight delay records, getting those into a feature store. Then those can be used by various groups. And here we took advantage of somebody else's feature group that they've been working on, where we completely avoid all of the effort involved to go and get the right data sources, do all the feature engineering work. All of that we can get for a really easy lift, just finding the feature group and grabbing that data and using it in new ways and new models. Okay, to summarize, we've taken a look at how to prepare data for machine learning with ease, speed, and accuracy. We've looked at two really important capabilities of SageMaker. One, Data Wrangler for fast and easy data preparation, and two, Feature Store to securely store, discover, and share features, both for real-time inference as well as training. And we've given you a few demos to show you how you can take advantage of Data Wrangler to prepare an entire data flow, export that, turn it into a reproducible feature pipeline, and then reuse features from multiple different feature groups to prepare and train a new model. So this is really going to help you with improving your models as well as improving your overall time to market, helping you move more towards ML at scale. Let me point out a few resources to help you move forward. First, for Data Wrangler, we've got a link here to the overall documentation, going through all the different transformations you've got available, how to use charting and so forth. There's a home page with all the product details, and there's a really good blog post on how to do exploratory data analysis, feature engineering, as well as operationalizing your data flow using Data Wrangler. For Feature Store, there's a good blog post on making ML-backed decisions in near real time using Feature Store, involving streaming ingestion. There's also another blog post on understanding the key capabilities of Feature Store. And then we've got a link here to the developer guide, as well as the detailed SDK documentation. And then lastly, at a broader level, we've got AWS Training and Certification offers more than 65 free machine learning courses online, on demand. And when you're ready, you can also take advantage of getting certified in machine learning. There's a specialty exam that you can take for that purpose. We also offer a ramp-up guide, and all of this is available for you in an attachment when you download after this session. So again, my name is Mark Roy. I appreciate you tuning in here, and I look forward to you trying out Data Wrangler and Feature Store and improving your time to market as well as the accuracy of your models. Thank you, and don't forget to also fill out the survey.